Good morning, everyone. I am LJ Miranda, and I am thrilled to introduce calamanCy, a Tagalog natural language processing toolkit. I was motivated to build this because I grew up speaking Tagalog. It is my native language after all. It is also spoken by at least 28 million speakers here in the Philippines. However, even with that scale, there's little to no resources for Tagalog. While I was working on Explosion, I helped maintain Spacey, another NLP library, and I realized that I can use that experience to build something for the Tagalog speaking community. And so today, I am excited to share how calamanCy fills this gap in NLP resources. calamanCy provides out of the box pipelines for core NLP tasks such as name entity recognition, dependency parsing, and parts of speech tagging. Each of these tasks is represented by a component, which we train from different Tagalog corpora. For example, we pre-train the token to vector weights using the TL Unified Pre-Training Dataset containing news reports and websites, and then we fine-tune each specific component based on that. More specifically, we use an NER dataset that we annotated for the NER component and the Universal Dependencies Tagalog tree banks for the dependency parsing and parts of speech tagging components. We then benchmark our pipelines across a variety of Tagalog datasets, and it remained competitive against cross-lingual and multilingual transfer learning techniques. Normally, these are the techniques you would reach out if you want to build a decent NLP model for the language. But now, you can skip thinking about which source language to use, you can skip fine-tuning large transformer models, and you can just use the more lightweight and efficient calamanCy pipelines. The charts below show our performance against these techniques, and you can see the full results in the paper. The way we use calamanCy is consistent to how we use Spacey. First, you load the pipeline, and then you pass the text you want to analyze. And all linguistic features will be encapsulated inside a special object. calamanCy also offers a high-level API in case you just want to do inference. Again, you can check the GitHub repository above for the documentation. Finally, we provide 3 pipelines of different sizes, 2 of which are word vector-based models from FastText and Floret, while the largest one is a transformer-based pipeline built on top of the Roberto architecture. Currently, we're also working on building encoder-decoder and decoder-only models to increase the number of tasks calamanCy offers. And that's it. Thank you for listening. If you want to check out the paper, you can scan the QR code above me. And finally, you can check out calamanCy on GitHub by going to the link way above. Thank you very much, or in Tagalog, maraming salamat.